So today, we are starting on 10-4. So we're going to spend a couple days on 10-4. Today we'll do notes. Tomorrow we've got work day tomorrow. And then 10-5, 10-4, 10-5. They kind of go together a little bit. Today's main topic is inscribed angles and what we do have to do with inscribed angles. So the whole goal today is to, one, learn the definition of what inscribed angles are. So we're going to of the world. And then we also want to be able to solve different problems with those inscribed angles. You have your guided notes here, so you don't have to do too much as far as no copying these things down. They're backwards, so you got to be a little bit careful. For some reason it's liking to staple up in the upper right-hand corner. I don't know why it does that. So there's slides up here, the same as the slides in your notes. So we've got inscribed angles today. So first and foremost, we've talked about inscribed angles before. Just again, want to give you kind of a little bit of a definition of what an inscribed angle is. An inscribed angle is an angle whose vertex is on a circle and whose sides are chords. Okay, so if right here, this is our inscribed angle. The vertex is on the circle. ED is a chord, and EF is a chord. So we've got this angle right here. That's considered to be an inscribed angle. It differs from that angle. Remember, that's a central angle because it's in the center of our circle. An inscribed angle is an angle that's vertex is on the circle, and it's made up of two chords. Now, the arc that it creates is called an intercepted arc. So this arc right here is called the intercepted arc. And we call that kind of the ice cream cone. This is the ice cream. The angle is your cone. This is the ice cream that you put on top. And that's the arc of our inscribed angle. So we say that DF is an intercepted arc and that DF subtends angle DEF. And you don't have to remember that. You just have to remember that this is an inscribed angle and that the arc that it creates is called an intercepted arc. Okay, and we've talked about these things before. That's not new. Now, what is new is the different properties that these have. So if you turn the page over, you've got essentially three different properties. But the thing with these properties is they say exactly the same thing with each of them. Okay. It says the measure of the inscribed angle is half the measure of the intercepted arc. So you can have RST, this one goes through the center. You can have RST where you've got them on opposite sides of the center. Or you can have RST where they're on the same side of the center. It doesn't matter what it is, whether it goes through the center, goes around the centers, or it's on one side of the centers. The measure of our inscribed angle is always, always, always going to be half of the ice cream that it created, or that's on top of it. So the angle is half the measure of the arc. If it's on it, it's half. Remember, if it was in the center, it was the same. When we had the central angle and the arc, they were exactly the same. If it's inscribed, it's half. So if I tell you that the cone down here, if we look at just this first one and we start putting some numbers in there, if I tell you that the cone in there is 60 degrees, the arc that it creates is double that. So the arc that it creates is going to be 120 degrees. It has to be. It has to be double of the angle that it creates. The angle is half the arc. So if we look at the second one, let's say in the second one, we know the measure of the arc, RT, is 140 degrees. What's the measure of the cone? What's half of 140? 70. 140 divided by 2. And that's all this is your arc measure divided by 2. That gives you the inscribed angle. If we look at this last one, I like going in that direction. So if I tell you that RT is 80 degrees, what's the measure of my angle? 40. Easy enough, right? It's half. The angle is half of the arc that it creates if it's inscribed. And if all of the problems just look like this, life is as easy as can be. So if we look at our first example, you see what happens now. Things become much more complex. You got all these things happening, and you've got a bunch of different inscribed angles within this problem. So it's kind of that same thing that we talked about when we talked about that central angle. Fill in what you know first, and then answer the questions that are sitting there. So if we look at this one, I've got that this is 118. That's representing the arc PU. Well, that's my ice cream. My angle that's created is this angle right here. So the measure of that angle has to be half of 118. So if I take 118 and divide that by 2, 59, that tells me that this is 59 degrees. The other thing that I notice that I have is I have this angle right here. Well, that's my cone. My cone is 27 degrees. My ice cream's double that. So 27 times 2 is 54. So my arc that's created, PS, is 54 degrees. Can I find anything else out in there? Can I find this? I don't think so. It's a cone. I mean, it's part of ice cream, but does it make any cones or anything? Same thing with this one right here. It's the ice cream, but it doesn't make a cone anywhere. We can only find the measures of cones. We don't have an ice cream cone. Okay, so we can't find it. So now if we look at our questions, PRU, SP is 54 degrees. And there are our two solutions. Just by knowing that the arc is twice the angle. The angle is half the arc. Okay. So get the next example. Again, gets much, much, much more complicated when we do these. And this is kind of, you've heard me say it before. These are the kinds of questions that I like because there's a lot going on in here. And a lot we can figure out just by using the skills that we have. So first thing I'm going to do is I've got no measurements, but they tell me that RST, that this arc from R to S to T, they tell me that that's 164. So I'm going to go ahead and put 164 there. Now I'm going to use that. I've created an arc, RST. So there's my ice cream. I need to find the cone. So T goes down to V, and then V goes out to R. So now I've got my ice cream cone. There's my cone. There's my ice cream. Here's my cone. So I can find the measure of that angle right down there. What's the measure of that angle? Or how do I find the measure of that angle? How do I find it? What do I do with the 164? Divided by 2. 164 divided by 2 is 82. So TRVT, the next thing, so I've got that one done. We said that's 82 degrees. Now I'm on a different question, so all of this is probably irrelevant now. So our next question says if SPU is 79 degrees. So I go to S, I go to P, and I go to U. So that's my cone. My cone is 79. Well, my cone creates this ice cream. That just also happens to be what we have to find. So if my cone is 79, how do I get to the arc? Is it half of it or do I double it? Double it. So I take 79 times 2, 158. So my arc is 158 degrees. It's double the angle. The arc is double the angle. The angle is half the arc. A little bit more complex, a little bit more challenging. Okay. So if we have something like this then, so I've got this angle right here. That angle right there creates that arc right there. Do I know the measure of this arc? Doesn't tell us, right? It's going to be double 5a plus 20. You know, technically, it's, and don't write this down, technically it's 5a plus 20. That's the angle times 2. Doesn't really help us. Well, let's look at this WY. What do we call WY? A diameter? It's a diameter, right? So if that's a diameter, what's this arc? How many degrees is this arc? 180. So we know this arc has to be 180 degrees, right? Because this WY is a diameter. And a diameter has to be 180. So I know that arc has to be 180 degrees. So let's pretend I don't know this. If I know that that arc is 180, what's the measure of that angle have to be? It has to be 90 degrees. Because by our definition, the cone is half the ice cream. So now I know that this also has to equal 90. So this angle equals two things, 5a plus 20 and 90. So I can go ahead and say, okay, then 5a plus 20 has to equal 90. A little longer to get there, a little bit more processing to get there. But in the end, we got there. Subtract 20. 5a equals 70. 5 times what is 70? Or 70 divided by 5 is 14. Hey Siri, what's 70 divided by 5?
70 divided by 5 is 14.
So our a value is 14. 5 times 14 is 70. 70 plus 20 is 90. It checks out. It works. Okay. But again, taking our time and using the different skills that we've gained throughout the year to do these problems. Okay. And that's going to come into play a lot today. So let's look at this one. So I'll do this one up here. So in the end, here's what's going through my brain as I'm doing this problem. This is what I have to find. I have to find the measure of that angle right there. I have to find this cone. If I look at this and I draw in the two chords that make up that inscribed angle, these two chords, XE and XW, make up my inscribed angle, and then this right here, that's my ice cream. If I can figure out what all of that is, then I can figure out what this is. Any ideas? What's that? If I subtract from these two things from 360, am I going to have that arc? Well, I know from here to here is 80. So 360 minus 80 is 280. So I've got 280 that still needs to be covered. I go this direction, I got to take off another 68 because I've used that. That's 212, right? So now does the rest of it have to be 212? Yeah. The rest of this arc has to be 212 degrees. So my ice cream is 212. I have to get to the cone. The cone is half the ice cream. What's half of 212? 106. Okay. Does it matter that I don't know this part from E to V and from V to W? Doesn't matter one bit. Don't need it. To answer the question that it's asking, I don't need it. Now, if I was asked to find this angle or this angle, then yeah, I need that. I know this isn't asked on here, but could we find the measure of that angle down there? Yep. If we look at this angle down here, angle V down here, angle EVW, EVW creates this arc right here. 80 plus that is 148. And then I could just divide that by 2 and get that that's 74. And so there's other things we could get on this problem as well. But again, it's about the little things. Knowing that a circle is 360 degrees. If I subtract off these different arcs, then I've created the arc that I need. And I can do the problem. Okay. Let's look at the next one. So let's just slide it over. All right, so I'm looking at my, again, this is what I have to find. So I've got this angle creates this arc. So if I can find the measure of this arc, I can find the measure of that angle. I know that's 112. Explain.
It's half the circle, so we 180.
How do you know that that has to be 180?
It's half the circle.
Okay, it's the top of the circle. So TR is a diameter, right?
Yeah.
TR is a diameter, 180 degrees. So if I take 180 minus 112, 68, that's what SR has to be. Arc SR has to be 68. How do we get to the angle? Divide by 2. So that's 34 degrees. But again, you got to keep your mind open to what's going on. Is there other ways to do it? Sure. You could have said that this is 180. And you could have taken 180 plus 112. And then take that 360 minus those two. You still get 68. TR is a diameter. And keeping those things in mind. Taking steps back. Sometimes before you take steps forward. Helps life out a little bit. Let's go to the next one. Getting a little bit more complex. So I have to find angle G down there. So I'm looking for this angle. So I like to figure out the arc that it creates. So there's one chord. There's another chord. I need to know all of that. So I know this is 144. I know this is 84. I got to figure out, ultimately I've got to figure out what that one is, right? And then if I add those three together, I can take half of it. So how does this, they put this 102 in there, does that help us any? It helps us find the GK, doesn't it? So this 102, it creates this arc right here, from E to K to G. Double it, right? So that whole thing is 200 and, so that's 204. So that's from here all the way around to here. I know that whole thing is 204, but I know this part is 144. So what can I do with the 204 and 144? Subtract them. So if I take 204 minus 144, 60. So that makes GK 60 degrees. 60 plus 144 is 204. Okay, I still don't have that one, but I think that helped us, right? What do they all have to add up to? 360. So I got 360. If I subtract 144, and then I subtract off 60, and then I subtract off 84, that's going to give me what's left in that arc right there. Hey Siri, what's 360 minus 144 minus 60 minus 84?
360 minus 144 minus 60 minus 84 is 72.
So that's 72. So that's 72 degrees. So does that mean that my angle right there is 36? Nope. Because I need the arc from F all the way down to K. So my arc is going to be 72 plus 144. 226. And then what do I have to do with the 226? Divided by 113 degrees.
I think that's wrong.
Did I mess up?
It's 216.
Oh, it is 216. I can't add. See, that's why I asked Siri. It's 216, so this is 123. Nope. So it's 108. Let's try that instead. That's why you ask Siri to add and subtract for you. Sorry about that. What's that? Yes. You got to take a lot to do these. You got to take a lot of thinking to do these. But that's what makes geometry more fun than algebra. Algebra is just a bunch of formulas. And you solve. These you actually have to think about. All right. Let's take a look at this one. Okay, I want you to go ahead and give this one a try by yourselves or with a partner. Give you a couple minutes. Why don't you go ahead and see if you can find the solution for the question mark up there. 2 minutes and 18 seconds. Find the value of the question mark down there. We are out of here at 1:48. reason from Office Depot. About another minute. Give it a shot. Try to figure it out. If you can't, that's fine. We'll go over here in a minute. But try to figure it out.
Can you check this? I got it wrong.
That gave you that and that. Then they have to add up too.
360.
Just want to do it, sure. Couple ways to do this one. You want to explain how you did it? You know, it's exactly right. No, you're right. The answer is right. Show me, how'd you do it?
I did 44 times 2.
Okay, so 44 times 2,
To get the C and D,
that gives us CB, so that's 80,
88.
88. What else did you do?
And then I did 80 times 2 to get B and D,
And that's 160.
60.
And then the question mark's going to be,
And then I did 360 minus 160 minus 88.
and that's what we had to find, right?
Yeah.
So that's 112 degrees. That's what you got too, right? Okay, so that's one way to do it. Works really well. There's another way to do it. Want to explain how you did it?
As I know that triangle size 180.
Okay, so that, remember the interior angles of a triangle have to add up to 180 degrees, right? So if I go 180 minus 44 minus 80, what's that give me? That gives us 56. So now I know the measure of that angle is 56 degrees. Since the measure of that angle is 56 degrees, the arc has to be 112. Same exact answer, two different ways to look at the problem. Both great ways to look at it. Both of them work. When I did it, this is the way I did it. But that's just it, but it worked either way. You just have to find a way that you're comfortable with. Okay? Let's look at the next one. Okay, so now we have that angle down there that's 4x plus 19, and it gives us the arc of 126. You need to find the value of x that makes this work. Give you about a minute. This one should be a little bit quicker. Give you about a minute 18 to do this one. Find the value of x. Knowing what we know and how we've done the problems, see if you can find the value of x. About 12 more seconds. So here's our angle down here that we ultimately have to find. It created arc DC. So if we ignore the 4x plus 19, we just ask what the measure of the angle has to be. What's the measure of the angle have to be? 63. Now we have to keep in mind that we do actually know it. We know it's 4x plus 19. So 4x plus 19, use a pin instead. 4x plus 19 has to equal 63.
Minus 19.
Subtract 19,
44.
divide by
4.
x equals. Everybody agree? Okay, nice job. Ooh. Okay, let's look at this next one. We'll do this one together. It's a little bit more complicated. All right, so again, kind of what's going on in my head. I know this arc is 20x. I know this is 15x plus 5. I know the whole thing is 360. So technically that's going to be 360 minus 20x, but I don't think that's helping me. I'm going to have a bunch of unknowns. So I don't know if that's helping me yet. What can we do with this? We can double it. Yeah, very good. We can double it. So if I'm going to take 2 times 7x plus 6, because it's twice it. So 2 times 7x is 14x plus 12. So now I know all of the arcs, right? What do all of the arcs have to add up to? 360. So if I take 20x plus 15x plus 5, all of those together have to add up to 360 degrees. That has to happen. Now, all of this stuff is on one side of an equation. Combine them, right? So we add our x's together. So we've got 20 x's, we've got 14 x's, and we've got 15 x's. 49 x's? I think so. I've got 12 and 5. 12 and 5 is 17. That's a nice 7. And that has to equal 360. Subtract 17. 49x equals 340. Is that divisible by 49? 7? Hey Siri, what's 343 divided by 49? Hey Siri, what's 343 divided by 49? 7. Siri didn't answer me, but he sounded an awful lot like Siri. Good question. Those are fun. Wow. What's that? Oh, we have to find the measured angle. We're not done. I didn't answer the question. We have to find EFD. My bad. We just found X. So we have to plug that in for 7. Great job looking. I didn't. 7 times 7 plus 6. 49 plus 6. 50. 55? Good catch. 55 degrees. I should learn to look at directions. Next one. Oh, shoot. So you have to find HA, so you've got to plug in X. You've got to find the value of X. So I know this. Times it by 2, it's going to give me this whole thing, right? 13 times 2 is 26. 6 times 2 is 12. So I know the whole thing needs to be 26x plus 12. But what also do I know it is? It's all of this stuff too, right? So what do I have to do with these two? Add them together and set it equal to, not 360, 26x plus 12. So we're going to go 8x minus 6 plus 19x plus 11. That has to equal 26x plus 12. Here's our equal sign. Got to combine like terms. It's 27 x's. Ooh, I like that. Negative 6 plus 11. 5?
I don't have the test together.
So that's equal to 26x plus 12. So I'm going to subtract 26x. And I'm going to subtract 5. 27 minus 26 is x. 12 minus 5 is 7. So we've got x is equal to 7. Is that the answer? Nope. We've got to plug it into HA. So HA is right there. 8 times 7 minus 6. 56 minus 6 is 50. That's a 0. 50 degrees. Any questions so far? Now, there are 2 more questions on the back. One more? Yeah. There's 1 more question on the back. That's your homework for tonight. See if you can figure out this 1 more question for tonight, and that's the only homework you have for tonight. We'll go over this question tomorrow to make sure we can do what we wanted to be able to do, which was find the missing angle, the inscribed angle, or find the intercepted arc. Okay, we'll do a couple of examples tomorrow, including this one, and then tomorrow will be a worksheet day. Good job today, everybody.